Let's take a look at page 2 of your assignment. And the question is, how much does it cost to manufacture the transistor in 1960? Well, notice from the question, 1960 was the year it started. So we're going to say T would equal 0 in this problem. In other words, C of 0 is 8 times 3/4 to the 0 power. Well, anything to the 0 power is 1. So it will be 8, or more specifically $8. Now, is the transistor price increasing or decreasing? Well, notice R is 3/4. And since 3/4 is less than 1, that tells us it's decreasing. Because we're taking the price each year by a number less than 1, so you're going to get a number less than 1. What's the cost to manufacture a transistor today? Well, today I'm going to go with what I'm making this video is 2023. So if we take 2023 minus 1960, T is going to be 63. So we're going to put 63 into our problem. 8 times 3/4 to the 63rd power. So let's use that on our calculator. So if we take 8 times 3/4, now you could type in 0.75, but I'm going to type in 3/4. And we're going to raise that to the 63rd power. Notice the number is so small, it's written in scientific notation. If we round it, we'll go 1.08, we'll say. That's 1.08 times 10 to the negative 7. We can actually write that, since I'm moving my decimal places 7 places to the left. I'm going to get 6 zeros. So 1, 2, 3, 4, 5, 6, 108. If I move it, that's in dollars, so if I move it over 2 places, that's still way less than a penny. Now, let's turn it around. They didn't ask this, but how many transistors could you make for a penny? Well, if I just take 1 cent divided by how much it costs for each one, I'll get about 9.2 million transistors. Okay? So I could make about 9.2 million transistors for a penny. And that kind of goes with what we called Moore's Law, that says the number of transistors we can fit into a circuit doubles about every year. Now on question number 24, we want to graph the college basketball games attendance. In 2015 was 6,500. So I think what I'll do is I will make my chart here. And I'll redo that because it's not very vertical. I'll make my chart here. And when I make my chart, I'm only going to use the first quadrant because you can't have negative attendance. And notice, excuse me, we're starting at 6,500, so I think all I'll do is I'll count by thousands. So that's 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, and I kind of ran out of room here, didn't I? So, luckily for me, I could actually just move this thing down. There we go. And I'll extend it up here. So here's 7,000 in my writing. So I'm going to start at 6,500. And then notice it's dropping at 7% per year. So if I think here, 100 minus 7, that's 93 then, isn't it? So if I write this as a geometric sequence, I'm starting at 6,500. And sorry about that. I got a notification here. I was trying to shut it off. So 6,500 times 0.93 to the t power. So let's estimate where is 1 going to be after 1 year. So I take 6,500 times 0.93. So let's go ahead and do that. So after 1 year, we're going to be at 6,045. So when I plot that, that will be about 6,045. Okay, let's go out 2 years. So if I go out 2 years, I'll just take my answer times 0.93. So about 5,600. We're going to round that too. So if I go 2 years, I'm at 5,600. Let's go out 3 years. So I'll take that answer times 5,600. Whoops. Try that again. Times 0.93. And we're at 5,200. So year 3, we're going to be up here at 5,200. Okay. I got room for year 4. So I'm going to take that answer times 0.93. It'll be at 4,900. When I say 4,900, I mean, yeah, something, did I mess that up? Because I got a huge number there, didn't I? Oh, the previous one, I didn't put my decimal in there. There we go. That makes more sense. Okay. So I was right. I just didn't look close at my decimal. So we're going to say about 4,900. You see how it's flattening out there? And we could draw a graph of that. Now, could I have done that in decimals? Sure, I could have. Let's take a look at decimals. So what I'll do is I'm going to do f of x. You could do y, but I'm going to do f of x. And that's going to be equal to 6,500 times 0.93 raised to the x power. And we'll have to adjust our graph here because we can't see it. So we'll click on our tool here. I want to start at 0. And 10 for x seems pretty good. And then my y-axis, you can't have a negative number, but we'll put our maximum at 7,000 like we did on paper. And then let's change our step to 1,000. Notice we can put a label on here. So I'll put time, or maybe I'll put year to label my x-axis. And I'll put attendance to label my y-axis. Then we can see that. And I always like to shrink it in just a tab so I can get that idea. So we can see that. Now we could have put the points in here. Remember, x can't be negative, so actually we're gonna start at 0 and then go from there. And I've got a little bit over 10 years in there. And I think that's it for that page. We got one more problem to do.